So we are going to not only graph these functions, we're going to analyze them. So we're going to start by finding the domain. All right, now this was actually part of the last lesson. Do you guys remember how to find the domain for logs? We have 3 domain restrictions, okay? What was the old 2 that we've done all year so far? The denominator can't be 0, so if there's an x in the denominator, we know to take the whole denominator, set it not equal to 0, and solve. What's the other situation you have to worry about? Yeah, even roots. Everything inside of the in root has to be greater than or equal to 0. And for logs, this is our new one. What do we have to worry about for logs? Everything in the parentheses has to be positive, okay? Now this goes from this, all right? If you have your domain, right, your domain of a parent log function is 0 to infinity because you can only take the log of positive numbers. So unless you're shifting left and right, it's always going to be from 0 to infinity. You have this asymptote here. So for this one, what is inside the parentheses? X plus 1. So we know that x plus 1 is greater than 0. So for finding the domain of logs, identify parentheses. If there isn't a parentheses, it's only the part touching log that is part of it. All right, so then you can put in the parentheses to see. But then you're going to set it greater than 0. So we know x is greater than -1. So this is -1 to infinity. Okay, so if we want to graph this, what is the transformation being done here? Are we going up, right, left, down, flipping, reflecting? What are we doing? We're left 1. It's always opposite of that inside value. This is left 1. So if we're going to graph this, all right, we know, again, for exponential, we know our points are 0, 1, 1 the base, -1, 1 over the base. So if on your test, if you guys write this, and then you write logs, now you have your reference. So if you memorize this, you know to flip-flop everything here. So if that's the case, then what I want to do is for my ordered pairs, I'm going to have 1, 0, and then the base 1. Well, what is the base for this problem? Log base. What is the base here? 3. The way to read this is log base 3 of x plus 1. That's how you would read this. So base 3. So it's 1. It's the base 1. So I'm going to put 3, 1. And then it's the reciprocal of the base, -1. All right, so these are my parent function points. But we decided that we are going what direction here? Left 1, which means what am I doing to x? So x minus 1. So I'm going to take all my 3 points here and subtract 1. What's 1 minus 1? 0. 3 minus 1 is 2. 1/3 minus 1 is the same thing as 1/3 minus 3/3. And what is that equal to? -2/3. So -2/3, -1. Now I also have the asymptote at x equals 0, but if I'm moving x left 1, then what's going to happen here? It's now going to be x equals, so I subtracted 1, subtracted 1, subtracted 1. What am I going to do? 0. Subtract 1, so it's x equals -1. All right, so these are my points. So again, for the quiz, if you have all of your points in your asymptote labeled, I'm not as concerned about you labeling them on the graph, all right? That'll just make it easier for me to grade. Obviously, if your points don't match what's on the graph, that you will lose some partial credit there. But if it seems to be in the vicinity of the points that you said, then I'm going to assume that you were trying to plot these, okay? So x equals -1 is our asymptote. We have 0, 0, 2, 1, and then -2/3, -1. Okay, so now we have our graph. What you can do now, you guys, is you can actually check your domain as well. All right, so if you look, our asymptote is at -1. We'll take a look at our domain, -1 to infinity. They match. Okay, so this matches what our domain is. So we just finished step 2. We did the graph. Now we're going to find the range and any asymptotes. What is the range of all log functions? The range of log functions. Always all real numbers. Okay, so again, write this down, use it as a reference. All right, so we know the range is -infinity to -infinity. The domain and the asymptote for log functions, similar to the range and the asymptote for exponential. Now the domain and the asymptote for logs, if you're not using the same number, you're doing something wrong. Okay, so for asymptotes, we know it's x equals, so be careful for that. So it's x equals, and for this problem, it's going to be x equals -1. Okay, and now we want to find the inverse. Okay, if you guys remember, we ask ourselves 2 questions. Do you remember what the 2 questions are? What's the base? And what's the exponent? All right, so here, if we flip-flop, we're going to have x equals, so instead of y, it's x equals log base 3 of y plus 1, and we're trying to solve for this y. That's going to be our inverse function. All right, what is the base of this problem? 3. What is the exponent? I'll give you a hint. Logs always equal exponents. So the exponent has to be x, because if this side has log on it, that means this side's the exponent. Logs equal the exponent. So here's the base. X is the exponent, equals what's left over? Y plus 1. What do we have to do next to solve? So we get here 3 to the x minus 1. All right, so that's your inverse function. And then they want us to find the domain and range for the inverse function. Do we need to use this as a reference to find the domain and range here, the 3 to the x minus 1? I mean, we could, but do we have to? No, why not? If these are inverse functions and I want the domain and range, what can we just use? The domain and range of our log function. So if the domain of the log function is -1 to infinity, where is that going to fall for the inverse? The domain of 1 is the range for the other. So now the range is -1 to infinity. And the range of the log is all real numbers, which means for the exponential function, the domain is all real numbers.